Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and its explanation based on states of matter. Now I will continue from the last class. Last class questions based on Boyle's law, Charles' law and absolute scale of temperature I was discussing. Now question number 16 I will do today. Question number 16 onward up to question number 15 I have discussed. Now I am reading the question. When a gas is compressed at constant temperature, 4 option is given. First option, the speeds of the molecules increase. Second, the collisions between the molecules increases. Third, the speed of the molecules decreases. Fourth, the collisions between the molecules decreases. Again I am reading the question one more time. When a gas is compressed at a constant temperature, the 4 options are there. First option, the speed of the molecules increases. Second, the collision between the molecules increases. Third, the speed of the molecules decreases. Fourth, the collision between the molecules decreases. Just you answer. Okay, this you can think. After that I will tell the answer. Just to think. Keep paper and pen with you. Sometimes it will help you. Now its correct answer is B, means the collision between the molecules increases. The collision between the molecules increases. Correct? Because you have compressed the gas at constant temperature. Then on compressing the gas, pressure increases and hence the collisions between the molecules increases. Hence option B is correct. The collision between the molecules increases. Now question number 17. The correct representation of Charles' law is given by 4 plots are given. First plot is volume versus temperature is a straight line. Second, volume versus temperature in Kelvin, both are in Kelvin. First option, second option. Here actually diagram you can see, then you will understand very clearly. 4 plots are given. First is volume versus temperature in Kelvin, and second is again volume versus temperature in Kelvin, but in first one it is a straight line, means from the top it is coming towards base, and second that is above the origin this line started and it went a straight line up. There is actually it is not from the origin, it is little above from there straight line went up. And third plot is volume versus temperature. This is also in Kelvin, but here a straight line is from origin. And fourth option is again volume versus temperature in Kelvin, but now this is a parallel to line is parallel to base. Parallel to base means x-axis. And first one option was from up to down. From up from this y-axis. It started from y-axis. It is a straight line, and it went to the base, far from the origin. Far from the origin. Then now just to think, which one is correct representation of Charles' law? Actually, if you have paper, you can write also. I can see the diagram. You will understand. Okay, first plot is volume. All are volume versus temperature, and all are in Kelvin. Then first one is from this thing, that is a straight line, but from the y-axis. It started from y-axis top, and it came towards base, means x-axis, far from the origin, but it is a straight line. And second, that is a little far from the origin. It started from the y-axis, far from the origin. It is a straight line, and it went up. And third, that is it is again a straight line, but origin is from the zero. It started from the origin, from zero. Okay, x-axis and y-axis, that coinciding from there it started. Okay, from the zero it started, it went up. And fourth, that is a line is that is a parallel to x-axis. Parallel to x-axis. This is also a straight line, and it is a parallel to x-axis. Now you have to tell correct representation of Charles' law. Just to think, you can answer it very quickly. Now its correct representation is C. Option C is, plot C is correct option, because now you know that this Charles' law, when temperature will increase, gas will expand, means volume will expand. Then with increase in temperature, volume increases. Correct? That's why with this it starts this plot that straight line started from the origin, and with the temperature, volume is increasing. Hence third option is correct. Third option is correct. Why it is correct? Charles' law is V upon T is equal to what? Constant. Means V is directly proportional to T. V is directly proportional to T. It means V upon T is constant. Hence plot of V versus T is a starting line passing through the origin. Now next question number 18. When gases are heated from 20 to 40 degrees centigrade at constant pressure, their volumes, first option, increase by same magnitude. Second option, becomes double. Third option, increase in the ratio of their molecular masses. Fourth, increases but to different extent. Again I am reading the question. When gases are heated from 20 degree to 40 degree centigrade at constant pressure, their volumes, first option, increases by the same magnitude. Second, becomes double. Third, increases in the ratio of their molecular masses. Fourth, increases but to different extent. Just to think, you think fast. because in exam you will not have too much time. Think in a right direction. After that I will tell the answer and explanation. Its correct option is D, means increase but to different extent. Volume, their volumes increase but to different extent, because there are gases, not only one gas. When gases are heated, it means there is not only one gas, maybe mixture. And temperature is actually it is heated from 20 degree to 40 degree centigrade at constant pressure. Then obviously volume will increase but to different action, okay, different extent. Why? Now I am telling you, different gases expand by different amounts when heated through the same temperature. Different gases expand by different amounts when heated through the same temperature. Now next question, question number 19. Actually these questions now onward will be based on ideal gas equation. Ideal gas equation. Question number 19. In the equation of a state of an ideal gas, PV is equal to nRT, the value of universal gas constant would depend only on first option, the nature of the gas, second option, the pressure of the gas, third option, the temperature of the gas, fourth option, the units of the measurement. Again I am repeating the question. In the equation of a state of an ideal gas, PV is equal to nRT, the value of universal gas constant would depend only on first option, the nature of the gas, second, the pressure of the gas, third, the temperature of the gas, fourth, the units of the measurement. Just to think in a proper way, you will get answer. I will tell the answer and explanation. Just to think in a fast way, in the right direction. Option D is correct. Means the it depends, universal gas constant would depend only on the units of the measurement. Why? Actually in the equation PV is equal to nRT, the value of R depends upon the units of measurement. Correct? Pressure, volume, N is there, small n, number of moles, temperature. Correct? It depends on the units of measurement. PV is equal to nRT. Remember, the value of R depends upon the units of measurement. Because pressure you can measure in different units, volume you can measure in different units, temperature, okay, temperature you can measure in different units, maybe Fahrenheit also, R also, means Romer also, degree centigrade also. Hence value of R depends upon the units of measurement. Next question I am discussing 20. Question number 20. Which of the following shows explicitly the relationship between Boyle's law and Charles' law? Which of the following shows explicitly the relationship between Boyle's law and Charles' law? You have to tell the relation between Boyle's law and Charles' law. First option is P1 upon P2, that is equal to T1 upon T2. Second, Pv is equal to K. Third, P2 upon P1 is equal to V1 upon V2. Fourth, V2 upon V1 is equal to P1 upon P2 into T2 upon T1. One more time, question I am reading. Listen carefully. Which of the following shows explicitly the relationship between Boyle's law and Charles' law? First option, P1 upon P2 is equal to T1 upon T2. Second, Pv is equal to K. Third, P2 upon P1 is equal to V1 upon V2. And fourth, V2 upon V1 is equal to P1 upon P2 into T2 upon T1. Just to think. It is a little difficult, but you can answer. Think it. And I will tell you answer and explanation. First to think. Its a correct option is V2 upon V1 is equal to P1 upon P2 into T2 upon T1. Option 4. How? Now I am telling you. Actually, combining Boyle's law and Charles' law, we get P1 V1 upon T1 is equal to P2 V2 upon T2. Correct? We know only from this relation you will find, when you will solve it, P1 into V1 upon T1, that is equal to P2 V2 upon T2. Only by use of this relation you will find, after cross multiplication you will find V2 upon V1 is equal to P1 upon P2 into T2 upon T1. Correct? Because P1 into V1 divided by T1 equal to P2 into V2 divided by T2. Then you do cross multiplication. Then you will find V2 upon V1. After cross multiplication you will find this only, V2 upon V1 is equal to P1 upon P2 into T2 upon T1. Next question, question number 21. The density of a gas is 1.4 gram per ml, means per cc. ml and cc both are same, milliliter and cubic centimeter both are same. The density of gas is 1.4 gram per ml at 1 atmospheric pressure and 27 degree Celsius. At what pressure will the gas have density thrice this value? The temperature is kept constant. Four options are given. First, same pressure. Second, 2 atmosphere. Third, 3 atmosphere. Fourth, 4.2 atmosphere. Again I am reading the question. The density of gas is 1.4 gram per ml at 1 atmosphere pressure and 27 degrees centigrade. At what pressure will the gas have density thrice this value? The temperature is kept constant. First option is same pressure. Second, 2 atmosphere. Third, 3 atmosphere. And fourth, 4.2 atmosphere. Just to think, you can answer it if you think in a proper way. Think fast. After that I will tell answer and explanation. Its correct answer is 3 atmosphere. 3 atmosphere. Now how I am telling you, just to listen carefully. Actually, expression you know, density is equal to Pm upon RT. D means density, D is equal to Pm upon RT, where P is the pressure, M is the mass, R is the universal gas constant, T is temperature. Then at constant temperature, when temperature is constant, then this by use of this equation you can write d2 upon d1, that is equal to p2 upon p1. Only by this expression d is equal to pm upon rt. Here T is constant. At constant temperature, by use of this expression, you can write d2 upon d1 is equal to p2 upon pm, because here mass for the same gas, mass is the same. Hence, if we will consider d2 upon d1, then because mass is the same and R is also same, T is constant. Hence, all will be cancelled. Correct? Then only D and P will be there. Then D is directly proportional to P, or you can tell D is equal to P. Then you can write D2 upon D1 is equal to P2 upon P1. If you compare at two temperature, both temperatures are same, then for the same gas, mass will be the same and R will be the same, temperature is constant, hence D is equal to P. That's why on the same concept you can write D2 upon D1 is equal to P2 upon P1. Then here, what is the P2 upon P1? Then it will become 3. P2 will become 3 because density is given 1.4. Density of gas is given 1.4 gram per ml at 1 atmospheric pressure at 27 degrees centigrade. At what pressure will the gas have density thrice? Correct? Means 3 times of given density. Correct? 3 times of the given density. Then it will become, by using this, d2 upon d1 is equal to p2 upon p1. Then if you will put the value, then p2 upon p1, then p2 will be p1 into 3 atmospheric pressure, because according to the question it is given that it should be thrice. At what pressure will the gas have density thrice? Correct? Then P2 upon P1 is equal to 3. It means P2 means a new pressure will be 3 into P1. Then correct option is, answer is option C, 3 atmospheric pressure. Now next question I am telling you, 22. If the absolute temperature of gas is doubled, actually this in question number 21 given that density was given 1.4 gram per ml. Correct? But here main thing is that this is at 1 atmospheric pressure. At 1 atmospheric pressure and 27 degree temperature. Then at what pressure density will be thrice? Density will be thrice. Then means thrice of 1.4. Then 1.4 will be cancelled. Then only 3 will remain. There is use of 1.4. Means 1.3 into 1.4 divided by 1.4. 1.4 will cancelled. Okay. Now question number 22. If the absolute temperature of a gas is doubled and the pressure is reduced to 1/2, the volume of the gas will, first option, remains unchanged. Second, be doubled. Third, increase fourfold. Fourth, be reduced to 1/4. Again, I am repeating the question. If the absolute temperature of a gas is doubled and the pressure is reduced to 1/2, the volume of the gas will be, first, remain unchanged. Second, be doubled. Third, increase fourfold. Fourth, be reduced to 1/4. Just you think. This is also little hard, not very hard. Little hard you can think. But you think fast. Okay, after that now I will tell the answer and explanation. Its correct answer is increase fourfold. Increase fourfold means option C is correct. Question is given, if the absolute temperature of a gas is doubled and the pressure is reduced 1/2, the volume of the gas will be, then it will increase fourfold. How? Now I am telling you. Here you have to just PV upon T. PV upon T, that P1 V1 upon T1 is equal to P2 V2 upon T2. That formula you have to remember. Correct? Then PV upon T1, that is equal to, now you have to put the value of new pressure, new volume, new temperature. P1 V1 upon T1 is equal to P2 V2 upon T2. Then original one is P1 V1 upon T1. Correct? Now new, what is the new pressure? Then half of the original means P by 2. Volume you have to calculate. Temperature is doubled means 2T. Then P1 V1 upon T1, that is equal to P2 V2 upon T2. Then P2 is equal to P by 2. Volume you have to V2 have to calculate. Temperature is 2T. Then just after simplifying, you will get V2 is equal to 4V. V2 is equal to 4V. Means 4 times, fourfold it will increase. Correct? Hence correct option is C. Option C is correct. Now next question, that is the question number 23. Question number 23 I am going to discuss. When the universal gas constant R is divided by Avogadro number N0, their ratio is called, very simple question. Okay, direct answer. When the universal gas constant R is divided by Avogadro number N0, their ratio is called, first, Planck constant, second, Rydberg constant, third, Boltzmann constant, fourth, van der Waals constant. Just to think, it is easy. Again I am reading one more time question. When the universal gas constant R is divided by Avogadro number, their ratio is called, first option, Planck constant, second, Rydberg constant, third, Boltzmann constant, fourth, van der Waals constant. Just to think it is direct. In 5 seconds you can answer. Just to think. After that I will tell the answer. Its correct answer is Boltzmann. Its correct answer is Boltzmann, because Boltzmann is equal to gas constant, universal gas constant R divided by Avogadro number. Okay, means what is the R value for one molecule or one particle or one atom? Avogadro number is 6.02 into 10 to the power 23. Particles, for that its value is R. Then for one particle, what is the value of R? Then R divided by Avogadro number. Then that ratio is called actually Boltzmann. Means R value for one atom or one molecule or one particle. Okay, whatever be, that is called, you can say, Boltzmann constant, a small k. It is represented by a small k. Now next question number 24 I am discussing. Which of the following expression represents correctly the variation of density of an ideal gas with change in temperature? First option, D2 is equal to P2 into T1 into D1 divided by P1 into T2. Second, D2 is equal to D1 into T1 divided by T2. Third option, D2 is equal to D1 into T2 divided by T1. Fourth option, D2 is equal to D1 into P2 into T2 divided by P1 into T1. One more time, question I am reading. Which of the following expression represents correctly the variation of density of an ideal gas with change in temperature? First option, D2 is equal to P2 into T1 into D1 divided by P1 into T2. Second, D2 is equal to D1 into T1 divided by T2. Third, D2 is equal to D1 into T2 upon T1. Fourth, D2 is equal to D1 into P2 into T2 divided by P1 into T1. I think you can answer it already. I have used one formula that you can use and tell. You think it. After that, I will tell the answer and explanation. Its correct option is D2 is equal to, first option only, D2 is equal to P2 into T1 into D1 divided by P1 into T2. This is the correct I can say relation or answer. First option only, P2 into T1 into D1, that is equal to P1 into that divided by D2 is equal to P2 into T1 into D1 divided by P1 into T2. Okay, how you will get this? Then relation is there. M is equal to dRT upon P. dRT upon P. Already you have used this relation while solving the numerical. D is equal to PM upon RT. Same. Okay, D is equal to PM upon RT. Then that time you have seen D2 upon D1, that was equal to P2 upon P1. Correct? Then now you will use same formula. That formula you can write also, M is equal to dRT upon P for a particular gas M. Actually, for a particular gas M, mass will be constant. For a particular gas, M is equal to constant. Then what you will get? D1 RT1 divided by P1 is equal to D2 RT2 upon P2. Then now here, after cross multiplication, just to get the value of D2, then you will get first option P2 into T1 into D1 divided by P1 into T2. Simply by cross multiplication, because now I told you that M is equal to dRT upon P, same formula what I have discussed earlier. Then M is constant for the particular gas. Hence, just to equate simply D1 RT1 divided by P1 is equal to D2 RT2 upon P2. Then RR will be cancelled. Correct? Then you will get D2 is equal to, after cross multiplication, D2 is equal to P2 into T1 into D1 divided by P1 into T2. Okay, no problem at all. Hence, first option is correct. Now next question I am telling you. Question number 25. The molar volume of CO2 is maximum at first option NTP, normal temperature and pressure, NTP. Second, 0 degree Celsius and 2 atmospheric pressure. Third option, 127 degrees centigrade and 1 atmospheric pressure. Fourth, 273 degrees Celsius and 2 atmospheric pressure. Again I am reading the question. The molar volume of CO2 is maximum at first option NTP, second 0 degree centigrade and 2 atmospheric pressure, third 127 degrees centigrade and 1 atmospheric pressure, fourth 273 degrees Celsius and 2 atmospheric pressure. This is also, you have to think, you can solve it, little tough. Okay, just to think. After that I will tell the answer and explanation. Just to think it. Its correct option is option C, 127 degrees centigrade and 1 atmospheric pressure. Correct? How? Now I am telling you. Here you have to use PV is equal to RT. PV is equal to RT. Then V will be what? V will be RT upon P. Hence V is maximum. V is maximum when T upon P is maximum. Correct? V will be maximum only when T upon P is maximum. Correct? This formula only you have to use. PV is equal to RT. Then V is equal to RT upon P. R is constant. Hence, if we want maximum V, then T upon P should be maximum. Here, actually, this V will be just after putting the value, that is the temperature. Temperature when you will put 273, R is okay, R is common, you can fix that, and pressure is 1. Then you will get 273, B is equal to 273 R. Okay, R is common, no problem, 273 R. And if pressure is 2, then now value will be less. If pressure is 2 atmospheric pressure, then value will be half of 273 R. And third option, if you can say this temperature is this things 400 R. 400 R option is given. Just to see the this thing's option, entire option, is to check it. Then you will find it that this option, that is the C option, you will find maximum value. Maximum value because 127 degrees centigrade plus 273, this is degree Celsius. Then 273 plus 127, how much? 400. And pressure is 1 atmosphere pressure. Hence, you will find in this case, you will get maximum value 400 R divided by 1. Correct? And in other you will see last D, then you will find 546 R divided by 2. Just only you just value you put and check it all. Check it all. NTP means you know. First option was there NTP, then normal temperature was 273. Pressure was 1 atmospheric pressure. Hence its value will be 273 R divided by 1. Second option is given, that is the this thing 0 degree centigrade and 2 atmospheric pressure. Then then 273 R divided by 2. Correct? This is again further less. Maximum in third you will find 400 R divided by 1. And fourth one you will get 546 divided by 2. This is also less. Hence maximum is 400 R divided by 1. Hence option C is correct. Here just temperature and pressure value you have to put. Correct? Then you will get 400 divided by 1 means 400 maximum. The molar volume of CO2 is maximum at 127 degrees centigrade and 1 atmospheric pressure. Good question. Okay. Now next question I am telling you. The gas constant R is a constant. The gas constant R is a constant. First option only for real gases. Second only for ideal gases. Third both for real and ideal gases. And fourth one neither for real nor for ideal gases. Again one more time I am reading the question. The gas constant R is a constant. First option only for real gases. Second only for ideal gases. Third both for real and ideal gases. And fourth one neither for real nor for ideal gases. It is that direct question answer you can think. You can answer directly within 10 seconds, less than 10 seconds. You think. After that I will tell the answer and explanation. Its correct answer is only for ideal gases. Option B. The gas constant R is constant only for ideal gases. Okay. R is constant only for ideal gases. You know you have read the ideal gas equation. Now one more question I want to discuss. The numerical value of n upon n, where capital N upon a small n, where capital N is the number of molecules in a given sample of gas and n is the number of moles of the gas, is, it's the first option 8.314, second option 6.02 into 10 to the power 23, and third option 0.0821, 0.0821, fourth 1.66 into 10 to the power minus 19. Again one more time I am reading the question. The numerical value of n upon n means capital N upon a small n, where capital N is the number of moles in a given sample of gas and n is the number of a small n is the number of moles of the gas, is First 8.314 numerical value you have to calculate. First option is 8.314. Second option is 6.02 into 10 to the power 23. Third option 0.0821. Fourth 1.66 into 10 to the power minus 19. Just to think, it is not very tough. You can answer it quickly. Its correct answer is 6.02 into 10 to the power 23. How now I am telling you. Capital N upon a small n, that is actually number of moles, number of molecules per mole. Correct? Capital N upon a small n, that is equal to number of moles, molecules per mole, because you are dividing it by what? A small n. Then a small n is the number of moles. Then per mole. Then per mole, what is the molecule? What is the molecule? Per mole. Then per mole, molecules you know. Per mole, how many molecules? Then Avogadro number molecules. Correct? Number of molecules present in per mole. That is the Avogadro number. Hence correct answer is B. 6.02 into 10 to the power 23. One more question. I will finish it only today. Then ideal gas, question based on ideal gasification will finish. Now question number 28. There is 10 liter of a gas at STP. Which of the following new conditions keep the volume constant? First option 273 K and 2 atmospheric pressure. Second option 273 degrees centigrade and 2 atmospheric pressure. Third 546 degrees centigrade and 0.5 atmospheric pressure. And fourth 0 degrees centigrade and 0.0 atmospheric pressure. One more time question I am reading. There is a 10 liter of a gas at STP, 10 liter. Which of the following new conditions keep the volume constant? First option 273 K and 2 atmospheric pressure. Second 273 degrees centigrade and 2 atmospheric pressure. Third 546 degrees centigrade and 0.5 atmospheric pressure. Fourth 0 degrees centigrade and 0.0 atmospheric pressure. Think it. This question also you can solve it. It will take hardly 30 seconds, not more than that. You think it. After that I will tell answer and explanation. Its correct answer is 273 degrees centigrade and 2 atmospheric pressure. Means option B. How? Now I am telling you. Here you have to use a P1 B1 upon T1 is equal to P2 B2 upon T2 formula. Then here V1 you have to calculate. Then what will be the V1 value? By cross multiplication you can get V1 is equal to, but here one more thing, you have to use this formula P1 B1 upon T1 is equal to P2 B2 upon T2. But here V1 according to the question, V1 is equal to V2. V1 is equal to V2 according to the question. In the question it is given, you want to keep same volume 10 liter. There is a 10 liter of a gas at STP. Which of the following new condition keep the volume constant? Means V1 V2 are equal. Then in this formula you keep V1 V2 equal, then both will be cancelled. Then you will get P1 upon T1 is equal to P2 upon T2. But P1 upon T1 is equal to what? P1 is a 1 atmospheric pressure, and T1 you keep 273, and P2 upon T2, then you will find P2 upon T2, you will get 1 upon 273. For B, just to see in condition B, 273 degrees centigrade and 2 atmospheric pressure. Temperature is 273, correct, and pressure is 2. Then you put this value. Then here in formula, P1 upon T1, P1 upon T1, then that you will get 1 upon 273. Pressure is 1 and temperature is 273, correct. Then P1 upon T1 is equal to P2 upon T2. Then this is the value for P2 upon T2, also same value, 1 upon 273. 1 upon 273. Then at that condition, second, that is the correct. Option second, 273 degrees centigrade and 2 atmospheric pressure, that is the correct. And only at this condition you will get this thing, volume will be constant. Okay, now I am stopping only here. Next class again we will meet. Thank you.